Hello friends, myself ASHWINI KUMAR from Institute of Medical Sciences and you are watching ASS tutorials. So if you have not subscribed my channel yet, please subscribe by clicking the red color button. Okay, today we are going to start photoelectric effect. We have completed heat portion and now we are moving for modern physics. In modern physics, first we will discuss photoelectric effect in this video. Okay, photoelectric part first will be discussed in this video along with many questions. So watch this video till last because modern physics give you 4 to 5 questions every year, and out of that photoelectric effect question is must in your every examination. Whichever examination you are going to face, in each examination photoelectric effect question is must. So it starts with photoelectric effect. Okay, now first we are going to see what is photoelectric effect. Photoelectric means photo means photon, electric means current production. Current production when photon strikes any metal surface. Suppose we are going with a experiment. Okay, so this is your cathode and this is your anode. Okay, this is your anode, and when we give a particular radiation here, okay, suppose UV radiation or something, then the electrons will be excited from here and electrons will move towards your anode because anode is positive and it is negative. Electrons are excited from this cathode, okay, and electrons will move towards anode, and this will produce current. So this is the basic idea about the photoelectric effect. Okay, moving for the theoretical part of this. Okay, so first one important thing is that electron will be excited from any metal. So suppose this is a metal. Okay, electron will be excited from any metal if it is given of a minimum energy. Minimum energy, suppose E. Okay, if minimum energy E is provided to that metal in the form of radiation, then electrons will be excited from that. If energy less than E, means suppose E dash, which is less than E, is supplied to the metal, then electron will be not excited. Okay, or if energy E double dash, which is greater than E, is supplied, then electron will be excited. Okay, electron will be excited, and after excitation it has some kinetic energy also. Again, this is the minimum energy E which has to be supplied to this metal so that electron can be excited from that metal. Part 2, if energy E dash, which is less than E, which is less than, this is the minimum energy, this is your minimum energy, and if energy that such as E dash, we have supposed that energy is the E dash, and if E dash is supplied to this metal, then there will be no excitation of electron because it is less than minimum energy. This is your minimum energy which must be supplied to this metal for excitation of electrons, but you are supplying less than minimal energy, so electrons will not be excited anymore. Now in next condition, you are supplying more energy than minimum energy, then electrons will be excited, and after excitation, because for excitation only E was required. Suppose you have given E dash which is equal to E plus half E. Suppose the energy which you giving E dash is E plus half E. So this E will be used in excitation of the electron, and this half E will be used as kinetic energy for that electron. Okay, so this is the basic concept behind the photoelectric effect. If you are giving energy E, which is a minimum energy to excite electron, then electron will be excited. If you are giving less energy than the required energy, that is minimum energy, then electron will not be excited from that metal. And if you are giving more energy than required, then electron will be excited, and along with excitation it has some energy which is going in the form of kinetic energy. Clear? So if you are getting E double dash, which is E plus half E, I have taken an example. So E will be going to, E is utilized to excite that electron, and half E will be going in the form of kinetic energy for that electron. Okay, so this is a basic idea behind that photoelectric effect. Now one more thing. Suppose this is your metal, okay, so when you give a light energy, to that metal, or any in the form of any energy you are providing to the metal, then the electrons will be excited. And suppose this metal is consist of thousands of electrons, okay, thousands of electrons. So for excitation of this electron will move to the surface of the metal, and then it will be excited, okay. And during excitation it also collides with other electrons present here, okay. So two things is happening. First, electron is moving towards surface for excitation, okay. And the second thing is happening, that electron collides with other electrons during movement, okay. Electrons also collide with other electron during movement, and when electron collide with other electron, then I am taking, and when electron collide with other electron, then it will release energy on collision. I am taking this Q is the energy which is lost, which is wasted during electron collision with other electrons, and E is moving, and this, and for an electron here to move up to the surface, okay, and from that excitation, that energy I am taking you as suppose phi naught. This is the minimum energy which is required for an electron to excite, means without any collision the electron is reaching here, okay. This energy is supplied to the electron for coming up to the surface and get excited. This is the phi naught, and this energy is utilized in the collision of the electrons. So you have to provide how much energy? Phi naught plus theta. You have to provide this much energy, then an electron can be excited from this particular metal. Clear? If you are not providing energy E, then electron will not be going to excited. It is clear? Okay. So this is the energy phi naught which is required for free an electron from the surface of the metal, okay. From the surface of the metal we want to free an electron, and the electron first moves to the surface of the metal, and then from that surface it will be get freed, and in doing that we are needing this phi naught, okay. I have not written proper. And one more thing, and during its movement electron collides with other electrons, and in collision they will release energy, that is Q. So the electron must be supplied with this plus this plus this. So this is the your minimum energy which I was talking about. This is the minimum energy required to excite an electron. Clear? But in ideal condition we assume that electron does not collide with other electron and the energy wasted is 0. So this factor will be not be useful for us. So directly E minimum is known as phi naught, okay. And this phi naught is known as work function. Phi naught is known as work function, and this is your minimum energy. This is your minimum energy required to excite an electron without any collision with other electrons. So this is the minimum energy for excitation of electron. This was the minimum energy, but this equals to this because we are assuming that electrons does not collide with other electron. But in questions, if you are provided with the data that electron collides with other electron and releases energy, wastes energy, then you must consider this part also, okay. Mind it, if you are providing any data for this type of energy, then you must consider this formula. But in general examination or in general we do not consider this wasted energy, okay. So this phi naught is work function, and this is equal to E. E was minimum energy to excite electron. So work function can be best defined as minimum energy which is required to excite an electron from a metal surface. Clear? This much clear? Now moving to the more forward. Now this is your minimum energy, okay. This is your minimum energy required to excite an electron. Clear? Now you are giving energy that is known as E. You are giving E energy, okay, which is greater than phi naught. Then I have told you this energy is used to excite an electron from metal surface, but you are giving extra energy because E is greater than phi naught. So extra energy will be utilized in the form of kinetic energy. Extra energy will be utilized by the electron in the form of kinetic energy. Electron will gain some kinetic energy after excitation due to your more energy. Okay, so mind it, the extra energy means E minus phi naught will be given in the form of kinetic energy to that electron. So this is the basic concept. Okay, getting. Now on the basis of this general concept, we have framed the formula that you can also frame that formula, that is a kinetic energy maximum is equal to E minus phi naught. Okay, and this E can also be written because we are giving the light, okay, and in the form of, and energy is given in the form of photons, so we have to put E, that is energy for photon, and energy for photon has formula, you all of you know, h nu. So you can put here h nu minus phi naught. Phi naught is your, this is your minimum energy. Okay, this is your minimum energy, and its formula is also, because it is a form of energy, so formula is same, but you have to put here this frequency is minimum frequency. Okay, this frequency is any frequency, means this frequency is usually greater than this or maybe same than this. Okay, so h nu minus h nu naught. Again I am telling, this is also energy, this is also energy. Okay, this energy is the minimum energy, so I have put this energy is minimum energy, so I have put this frequency is your minimum frequency. This is your minimum frequency to excite an electron, because when we are talking about energy, we are talking about frequency, because energy is equal to h nu. H is your constant, so energy is directly proportional to frequency. So whenever we are talking about energy, we are indirectly talking about frequency. Mind it, again I am repeating, whenever we are talking about energy, we are indirectly talking about frequency. Clear? So this phi naught is your minimum energy, so this frequency will be minimum frequency. Okay, because energy directly proportional to frequency. And this E, which I was talking about, this E is the supplied energy to that metal. This E is the supplied energy to that metal. This phi naught is not supplied energy to the metal, it is the inherent property of that metal. Means this phi naught is required for the metal. Means if you are going to excite any electron from this metal, you must need energy, that is phi naught. That is, you must need frequency of, the radiation of frequency must be phi naught, energy must be phi naught, and the frequency must be this much. Okay, this much frequency is must required if you are going to excite any electron from this metal. So this is the requirement, this is not you are supplying, and you are supplying energy E. This energy E may be greater than phi naught, this energy E may be lesser than phi naught. Okay, this energy E may be equal to phi naught. It means the energy which you are supplying in the form of radiation, it has frequency rho. Okay, this frequency, sorry, rho. Okay, so this frequency, and suppose this frequency is your f1, I am taking frequency f1. Okay, and acquainted with this, suppose this frequency is f1, so f1 may be greater than fo. Okay, I can write this as also as fo. Okay, I can write this as also as f1. We can write nu as f1 f0, so you can easily correlate with frequency. Okay, no matter, you can write nu or you can write f1 fo. I am writing f1 f1. So in this condition, energy is greater than your phi, so f1 must be greater than fo. In this condition, f1 lesser than fo. In this condition, f1 equal to fo. I want to tell that this is the energy which you are supplying from external, and it may be equal to this, maybe not be equal to this. Okay, less than this, or maybe equal to this. And in the same way, you can also correlate frequency, because energy is, when we are talking about energy, we are talking about nothing, we are talking about just frequency. Okay, so what we have done, we have K energy maximum is E, which is supplied energy, minus minimum required energy. So this is the, if you are getting here something positive value, if you are subtracting after doing this calculation, if you are getting positive value, it means that electron must have some kinetic energy. If you are getting negative value after solving this, it means electron will not going to excited, electron will not be excited, because if you are getting negative value, it means that if you are getting negative value, it means that phi naught must be, phi naught is greater than E, means required energy is more than what you are supplying, and if supply is less, then electron will not be excited. And if you are getting zero value, then it means electron has been excited, but electron has kinetic energy 0. Clear? So this is the basic formula which I am going to use in doing many questions. Okay, so please be clear with each of the terms which I have explained in this video. Okay, now we are going to discuss some questions upon this. Okay, you will get one more thing. 2 important points about photons. Okay, one photon can provide energy to only one electrons. Okay, one photon can collide with one electron and supply its energy to only one electrons. Means one photon can supply energy to only one electron, not more than that. Mind it? Okay, so suppose if you are increasing number of photons, mind it, very interesting concept is there. If you are increasing number of photons, it means you are increasing indirectly number of electrons which are going to be excited, because one photon collides with one electron. So if you increase number of photons, then number of collision will also increase, because one photon is giving energy to one electron. If you have increased number of photons, then the number of electrons which are going to be excited will also increase due to increased number of collision. Okay, number of electrons excited will also increase. And I am supposing that the photon frequency, that is nu, that is suppose f is greater than f naught, means this is the minimum frequency to excite the electron of particular metal. Suppose this is a particular metal which has minimum frequency of f naught. If this much frequency is given, the electrons will be excited, and if you are giving f frequency which is greater than fo, means electrons can be excited. Clear? Okay, this photon is of f, so after putting this photon on metal, electrons can be excited. This is clear. What I am telling, that one photon will excite one electron, one photon collides only one electron. Mind it, this is the basic law. One photon only collides with one electron, so one photon can give its energy to one electron. So if you are going to increase number of photons, it means you are increasing number of collision, because one photon collides with one electron. If you are increasing number to 50 photon, then 50 photon will collide, so 50 electrons, and these 50 electrons will be excited. These 50 electrons will be excited because this 50 photon which are coming of having frequency f, each of having frequency f, and frequency f is more than required frequency, then this 50 electrons will be excited. And if number of electrons excited will be increasing, then current will be increased. Why current is increasing? Because I have told you that current is your charge upon time. Okay, and charge, one electron charge is suppose 1 minus e. When we are supposing to 50 electrons, it means 50 e. So charge is increasing, movement of charge is increasing, the amount of charge which is going to move is increasing, because 50 electrons is going, so current will also be increased. Okay, so you can correlate with this. It means if you are increasing number of photons, then amount of current is going to increase. If you are increasing number of photons, then the amount of current is going to increase. One thing, this is the basic concept. Okay, and many students mistake in this. Now one more thing I am going to tell you. Here conclusion is our, if number of photons increases, then current will increase. Condition is that the upcoming photons is high frequency more than FO. Now if you are suppose if number of photons is increased, then current will increase, no problem. Now come to the second part of the you have fixed number of photons. Okay, you have fixed the number of photons. Suppose you have fixed that only 2 photons will be given to the metal. Only 2 photons will be given to the metal per second. You have fixed the number that only 2 photons are going to strike the metal per second. So 2 photons is coming, so only 2 electrons will be excited. If you have fixed the number of photons per second, that is 2 photons per second, and you are not going to increase any number of photons, it means 2 photon is coming, so it will excite only 2 electrons. And if 2 electrons is excited, means 2 electrons per second is excited. Mind it, 2 photon per second is coming, so 2 electron per second will be excited, because 1 photon always excite 1 electron, so 2 electron per second excited. And you can also put this as a charge. 2 electron charge is excited per second. Current is Q upon T. Current formula is charge upon time. So this is the charge and this is the time, charge upon time. It means current will be constant for the entire time period, because the number of photons striking metal per second is constant, then current will also be constant. Okay, so if you are going to fix the number of photons, then current will not change, but if you are increasing number of photons, then current will change. One more thing here, if you have fixed the number of photons, okay, no problem, you have fixed the number of photons, and you are increasing the frequency of photon, means now frequency was F. Suppose this condition, in this condition 2 electrons was excited, okay, 2 electrons was excited, current was same, and frequency was F. F means the electrons which are excited from here have kinetic energy H, falling frequency is F, and required frequency was F naught. So this much kinetic energy was with both electrons. This electrons also has this much kinetic energy, this electron also has this much kinetic energy. Clear? Now what you have done, you have increased the frequency of photons, means this is the frequency of photon F, and now you are giving F dash, which is greater than F, but you have fixed the photon is again the same, 2 photon per second is striking on this metal. 2 photon per second is striking on this metal. Now 2 photon per second is striking on this metal. Okay, you have fixed number of photons here, but here this photon is a frequency of F, and here this photon is frequency of F dash. No matter whatever the frequency, if frequency is greater than this, then electrons will be excited and have some kinetic energy. Here F, which is greater than F naught, then electrons excited and having some kinetic energy. Again here electrons will be excited and having kinetic energy something, but here kinetic energy is more than this, because HF dash minus HF naught. So this is the constant in both, but this HF is lesser than HF dash, because F dash is more. Understand? Think. Suppose you have to minus 5 minus 2, and you have to subtract 5 minus 3. Okay, so you will get 5, like suppose 5 minus 2 and 6 minus 2, you will get here 4, you will get here 3, because this part is constant, but this part is varying, this 6, suppose this is your HF dash, because F dash is more, so HF dash will be more, and HF will be 5, so you are getting more answer here, less answer here. So same like this, here kinetic energy is more, but still kinetic energy is more, but when you are going to calculate current for this, current will be same, because current is dependent upon charge upon time. If you are giving up 2 photon per second, then it will excite 2 electron per second. Okay, and if 2 electron per second is excited, then the charge will be 2 electron upon second, means current in this condition and in this condition both are same, because current has no relation with your frequency. Whatever frequency you are giving, it has no effect on current, because current is dependent upon number of photons. If you are increasing number of photons, then number of simple understand, current is dependent upon number of electrons. I am again repeating this same. This is the must which you have to understand in this video. What you know, current is charge upon time. Okay, this is a charge total, and how we will calculate charge total? Charge total is calculated by number of electrons into charge of electron, into charge of electron. And if I am assuming the charge of electron is equal to 1 electron, okay, 1 electron, this means minus any will be the Q total means number of electron. If suppose number of electron is 10, then the charge will be minus 10. Okay, because the current is produced through the movement of electrons, suppose. And so you are clearly seeing that current is directly dependent upon number of electrons. So Q total is minus Ne. You put here I is equal to Q total. Q total is minus Ne upon time. It means current is entirely dependent upon number of electrons. Current is entirely dependent upon number of electrons. So in the case when you are increasing number of photons, then number of electrons will also increase, and if number of electrons is increasing, then current will be also increased. But when you have fixed number of photons, and increasing the frequency of photons, so number of photons is fixed, so number of electrons which are going to be excited will be fixed. So number of electrons is fixed, then current will be fixed. But you have increased frequency, then kinetic energy of that excited electron will be increased. No matter, clear? So this is the basic theory behind your photoelectric effect. We will solve many questions based on this in next video. Okay, so thank you for watching. If you have liked the video, please subscribe my channel and share with your friends. Thank you.